8.5, variation functions. So this is all about just how to solve problems that deal with variation. Now there's different types of variation. There's direct variation, which we're going to deal with first. There's joint variation, which is very similar. And then there's inverse variation. What does that mean? Well, variation in general just means, direct variation in general, it just means as x goes up, so does y. They're both going in the same direction. Or likewise, as x goes down, y goes down. A very easy example of this is how long it takes to get to school compared to how far you live. So let's just be distance from home, distance from school, and let's just be how the time it takes to get to school. Right? If you live like a block down if you live like down the street, it's gonna take you like very little time to get to school. Now, if you live a little further, it's probably take you a little longer, and so on and so on. Right? If you live in like Victorville, it's probably take you like 2 hours to get to school. Probably not the smartest decision to go here. Now it could change, right? Some people might live like 3 blocks from school and walk, and they're like take a little time. They might live 3 blocks from school and be lazy and drive a car, so it's a little faster, right? Some might be slow drivers, some might be fast drivers. But in general, as you go, it's a direct variation. The further you live from school, the longer it takes to get to school. We call that direct variation. And the formula for that is this right here: y equals kx, where k is called a constant variation. So as we do this, you're always gonna have a k. K is a constant variation. So we're gonna say something like distance from school varies directly as time it takes to get to school. This will be our equals k. Right? Distance, y, varies directly as time takes to get to school. Something to that effect. So that's direct variation. As one goes up, the other goes up. I think this is like your height with your length of your arms or something like that. Like it's direct variation. Whoever knows. Anyway, this is how we solve this. So let's look at the problem. Example 1. R varies directly as t. So let's come up with an equation for that. So step 1 with this stuff, come up with an equation. So I'm going to have R equals, now varies directly, remember, is equals k, equals kt. So that's my equation. Now look what it says. And R is -20 when t is 4. Find R when t equals -6. So step 1 is finding an equation. Step 2 is to find k. Now look at, they give you 2 things here. They say when R equals -20, t is 4. So we're going to use this right here to find k. Right, so I can plug it in. R is -20. T is 4. Let's find k. So divide by 4. K equals -5. So step 1, come up with an equation, which we did. Step 2, find our k, because they give you a value to find k. Step 3, plug k in. Plug k back into the original equation. Plug back into the OG equation. So we're going to plug it right here. Right, so R is going to equal -5t. So that's our equation now. Like that's the equation we have. And then the last thing we're going to do, find R when t equals 6. Now we just use the equation to find the variable we need. Use the equation to solve. Right? Because now I know. It's like, okay, I have my equation. And now they tell me, hey, find R when t equals -6. So let's plug in t for -6. -6 for t. And I get R equals 30. So, right, that's the process. We go, okay, we have an equation, set it up, use the information they give you to find your k. Once you have your k, plug it back in. So now you have your actual equation. And once you do that, you can just solve the problem. That's the general idea. And we're going to do this over and over again. It doesn't matter if I say direct, which I am right now. We're going to say joint later. We're going to say inverse. It's all going to be the same. Come with your equation, find your constant variation, which is k. And then, so once you do that, you have your equation. You can do anything you want. So let's do another one to practice. So let's look at this one. Y varies directly as x. So first step, come up with the formula. So y equals kx. Right, that's our formula. Then they say, and y equals 12 when x equals 8. So we're going to use this to find our k. So I'm going to go, okay, y is 12, x is 8. Divide, k equals, you can reduce it if you want, divide by 4, 3/2. So once I have that, I make my equation, plug it back in. Y equals 3/2 x. So that's my equation. Now look what they want. Find y when x equals 14, sorry. So plug in 14 for x. This reduces, and you get 3 times 7 is 21. So y is 21 when x is 14. Again, that's the general idea. We're going to do this over and over again, but that's the general idea of how we do this. You set up your equation, find your constant variation. Now you have your full equation, and now you can solve anything you want to solve. So that's direct variation. Let's talk about joint variation. Joint variation is like direct, except there's more than one thing. So joint variation, when I say that, there's going to be two things. It's like y varies directly with k. Sorry, y varies directly, that's the k, with x and z. It's like, oh, there's two things. That's all joint variation is. It's direct, plural, basically. That's it. Other than that, it's the exact same thing, right? Let's do an example. Suppose r varies jointly as v and t. So again, all that means is, okay, r varies, so equals k. Jointly, this means to be more than one, v and t. So, boom, equation. Right? R varies jointly as v and t. Other than that, we do the exact same thing we always do. Find r when v equals 2 and t equals 8, if r equals 70 when z equals 10 and t equals 4. Now, this one's a little different. Find r when v equals 2 and t equals 8. This is what they want. I can't plug that in because I don't have r, and I don't have k. I'm actually going to plug in this. After the if part, that's what I'm going to plug in. This is a given. That's what I use to find k. Right? Because I actually have everything. I have r, I have v, and I have t. I'm going to use that one. The if part, I'm going to use that to find my k, because it has everything I need. So 70, k is this k. I'm looking for that. V is 10, and t is 4. So simplify it. 70 equals 10 times 4 is 40k. Divided by 40. K equals 7/4. So that's my k. Right, as always, once you find your k, plug it back in. R equals 7/4 BT. Right, so that's my formula. Again, once you have your formula, you're pretty much done. All you gotta do is figure out what they want. They want R when V equals 2 and T equals 8. So plug it in. Reduce a little bit. This and this cancel. I get 2. I get 2 times 2 is 4. 4 times 7 is 28. And that's the idea. Let's look at the next one. So again, more of the same thing. Suppose y varies jointly with x and z. So you go, okay, y equals k, x, and z. Right? Varies jointly. There's your equation. Jointly, this means they're both on top. Find y when x equals 6 and z equals -3. So again, I have to find something. That's my given. Sorry, that's my want. So I'm looking for. And then they tell me if y equals 20 when z equals 5, x equals 10. That's the given. Right? That has everything I need. Has my y, has my x, has my z. Right? I could use this to find my k. Divide by -50. K is 1. It's an easy k. Plug it in. Once you find your k, right, you plug it in and you get your equation now. So that's my equation. And now again, once you have that, you're done. Just find anything you need. So they want y when x equals 9 and z equals -3. Plug it in. Y equals 1 times 9 times -3. -27. Done. Right? That's all it is. No matter what type of variation I give you, you do it the exact same way. Right? Set up your equation, find your constant variation, plug it back in, and solve what you want to solve. So we've done jointly and we've done direct, both on top. Now let's talk about inverse variation. Inverse variation, right? So this is the opposite. Inverse variation says as one thing goes up, the other parameter goes down, and vice versa. Right, so example of that is, let's talk about temperature, degrees Celsius, Fahrenheit outside, and let's say sweater sales. Right, when it's pretty cold outside, you're probably gonna get a lot of sales. People want sweaters, but once it gets hot, it's like 90 degrees out. Unless you're buying it on sale, you're probably not gonna buy as many sweaters. So same side effect. Not the best example, but that's all I can think of. So sue me. So that. right? That's an inverse variation. As temperature goes down, winter clothes the demand for winter clothes goes down. As temperature goes up, winter clothes goes down, is what I meant to say. So that's the idea there. Right? And how do we solve it? Well, the equation is a little different. Since it's inverse, as one goes up, other one's down, the equation is y equals k over x. Right? In this case, as y goes up, your x goes down, and vice versa. So that's an inverse variation. Notice k is always on top. Always. But inverse means you're dividing by it. It's on the bottom. Other than that, we do the exact same way. So let's look at, for example, if x varies inversely as y. So again, key is make the equation. So x varies inversely, so equals k. Inversely means you put it on the bottom over y. That's my equation, right? Varies inversely means on the bottom. Now what they tell you, nx equals 24 and 1 equals 4. We're going to plug that in to find our k. So 24 k over 4. Now we solve this by multiplying both sides by 4. And we get k equals, let's see, 96. So that's my k. And as always, plug that into your equation to get your actual equation. So we have our equation now. X equals 96 over y. And like always, the last thing you do is, once you have your equation, you can do anything you want. Find x when y equals 12, so plug it in. And you can simplify that, and I think you get 8. And that's the answer. Again, same concept, just a different way of setting it up. So let's do another one real quickly, right? Y varies inversely as x. So you can set up, okay, y varies, so equals k. Inversely means put it on the bottom. There's my equation. And then they tell me when y is negative 8, x is 16. So plug that in. So negative 18 equals k over 16. We solve for k by multiplying both sides by the denominator. And we get negative 288. So as always, plug it in. Our equation is now this ugly mess over x, right? That's my equation. And then look what they want. Find x when y equals 9. So plug in 9. Negative 288 over 9. 9 goes in 288 3 times. And then to 27, so 18, so 2. 32. Negative 32. Right? That's how you do inversely. So now we've done inversely, we've done joint, which means they're both on top, and we've done direct, which means only the one variable is on top. We have one more to do, and that's joint. That's when we put it all together. Or actually, they call it combined variation. Sorry. Combined variations, you combine it. It's a combination of two. So you might say like you're direct with x and inverse with y. So you're just going to have something like z equals kx. Inverse means put on the bottom. Why? That's all it is. What goes direct goes on top, what's inverse is on the bottom. That's it. So let's do this first one. Suppose p varies directly as r. So I'm like, okay, p equals k. Because remember, varies is equals k as r. So on top, right? Directly is on top. And p varies inversely with t. So t goes on the bottom, right? P varies directly with r and inversely with t. So like that. That's my equation. Other than that, we do the exact same way we always do. Find t when r equals 10 and p equals negative 5. That's the want. We need our given to find the actual value. If, here it is, this is what they give us. T equals 20 when p is 4 and r is 2. See, I have everything I need to find k. I have this right now. Solve for k, multiply both sides by 20. And you're going to get 80 equals 2k, divide by 2. K equals 40. Now remember, we're not done. We just found our k, so now we can plug it in. Here's my equation. Right? That's my equation. Have my k. And all we do now is find what they want. They want t when r is 10 and p is negative 5. So plug that in. So r is 10, p is negative 5. Now this is a math problem, right? How do we solve it? We'll multiply both sides by t, because get that out of the denominator. And I'm going to get negative 5t equals 400. Divide by negative 5. And I get t equals negative 80. right? It's the exact same concept over and over again. All we do now, only difference is the way you set up your equation changes, right? Direct is on top, joint's on top, inverse is the only thing that goes on the bottom. So let's do this one real quick. Suppose A varies directly as B and A varies inversely as C. So A varies directly as B. B is this way. And inversely as C. So like that. That's my ugly equation, right? Again, look what they give us. They give us that. They want to find B when A is 2 and C is -3. And then they give us this. Right? That's how we're going to use it to find our K. Has everything we need. So we plug it in. A is 4. K, B is 16. C is 2. I can reduce real quick. That's 8. So 4 equals 8K. Divide by 8. K equals 1/2. Have my K. Plug it in. A equals 1/2 B over C. And again, once you have that, you're pretty much done. All you gotta do is plug in what they want. They want find B when A equals 8 and C equals -3. So I have this. Multiply both sides by -3. -24 equals 1/2 B. Multiply both sides by 2. And I get -48 equals B. Right? Again, it's the same thing over and over again. Set up your equation. Once you set up your equation, find your constant variation, find your K. Once you have that, you can set up your actual equation. And once you have that, you can solve anything you need. A few more and we're done. So this next one. This next one you actually don't need to do inverse variation. Just get set it up. A map of Illinois scales so that 2 inches represents 15 miles. How far apart Chicago and Rockford if they're 12 inches apart? Right, honestly, this use proportions. You have 2 inches, 15 miles. They tell you that Chicago and Rockford is 12 inches apart. So how many miles apart? Well, you just set up a proportion. And they could cross multiply. 2x equals 15 times 12. Divide by 2. 6 times 15. And that is 30 times 3, so 120. They're 120 miles apart. Right? So sometimes you don't have to overthink it, just, oh, proportions. Solve the proportions. This next one. Determine whether this shows direct variation, inverse, or neither. So remember, direct variation is this. Inverse is this. And neither will be none of those two. Right? So how do we do this? Well, what you do is what you want to do is you want to plug a few of these in to see if you get a constant K. Let me show you what I mean. So let's do this one first, right? So x8, y2. So you're like, okay, this is 2, K, x is 8. If I solve for it, I get K equals 2 over 8 or 1/4. Okay, so 1/4. Let's do the next one then. I get 4 equals K times 4. Divide by 4. K equals 1. Those are not the same. So it's definitely not direct. Right? Again, you want to get the same K every single time. So I tried direct, not direct. Let's try inverse. Right? So again, y is 2, K over 8. Multiply both sides by 8. K equals 16. Okay, let's see if we get that again. 4 equals K over 4. Multiply by 4. K equals 16. Looking good. I could try a couple other, but look, if you do it again, you're going to get the same thing. -8 equals K over, I think I wrote this something wrong. I'm right. -8 equals K over -2. Multiply, K equals 16. Right, I'm going to keep my gain 16, so it's a inverse variation. That's all you do with these. So I give you a chart like this. You could try to see if X is going up, Y is going down type of thing, and that gives you a good start, but sometimes it's hard like this one, you can't really tell. So what do? Plug it in, try to see if you get the same K. If you don't get the same K, it's not that one. If you do, it is. If on both of them I didn't get it, it'd be neither. That's the way it works. Okay, let's finish this up. Next one, if A varies jointly as B and C, find A when B equals 4 and C equals -3. So what happens here is this. They want you to use this as like the given. So that's the given. They're saying, hey, A varies jointly as B and C. So remember what jointly means. Jointly means they're both on top. So varies equals K. Jointly, right? Only way it goes on bottom is inverse. So jointly means they're both on top, B and C. We're going to use this right here to find out what our K is. So plug it in. negative 96 equals k times 3 times negative 8. Negative 96 equals negative 24k divided by negative 24. And you get k equals 4. Negative 4. And a 4, positive 4. That's my k. Plug it in. Now you have your equation. What do we do next? We plug in what they want. Find a when b equals 4 and c equals negative 3. So a equals 4 times 4 times negative 3. So I get negative 12 times 4, or negative 48. Right? So that's a kind of good review. We've been doing stuff like that, but it's the same thing, right? Varies is always equals k. Jointly means they're both on top. And always the same thing. Find your k with the given. Once you find that, you have an equation, and you can solve anything you want. Let's look at this application problem. So, every year, students at West High School collect canned goods for a local pantry. They plan to distribute flyers to homes in the community asking for donations. Last year, 12 students were able to distribute 1,000 flyers in 4 hours. Write an equation that relates the number of students S to the amount of time it takes to distribute 1,000 flyers. So, a couple things here. First, we're talking about 1,000 flyers for each one, so it really doesn't, 1,000 flyers really doesn't matter. That's just saying, hey, we're talking about 1,000 flyers. Let's talk about the rest of it. Number of students and how long it takes. So, write an equation that relates the number of students to the number of time it takes to distribute the same amount of flyers. Well, think about it logically. The more students you have, the less time it's going to take to distribute flyers. That's inversely related, right? If you had 2 students, it take you a while to distribute 1,000 flyers. If you have 1,000 students, it's not going to take that long. So our equation is going to be time is inversely related to students, right? Varies inversely with the number of students. So that's my equation. Now I got to find our k like always. Well, right here they tell us last year 12 students took 4 hours. So here's my t and my 12 students, my s. So I have 4 equals k over 12 multiplied by 12. K equals 48. So my actual equation is this. Time is inversely related with 48 over s. So that's my actual equation. Then it says, how long would it take 15 students to hand out the same number of flyers from last year? Well, students is s, right? So plug it in. T is an equal 48 over 15, and you can get some decimal and get your answer. Right, that's the idea though, right? Inverse relation, so set up the equation. Once you do that, use that to find your k. And once you have that, you can plug in anything you want. We'll skip this one to the same idea. Last little thing here. So all this wants to know, is this a direct or joint variation and named variation? Now look at this one. A equals 3bc. So which one is it? Now notice that there's 2 things on top, nothing on the bottom. So again, bottom is inverse. This doesn't have that. So this is a joint variation. Joint, right? Direct would be one thing on top, like this. Joint is when there's 2 things on top. Inverse is sitting on the bottom. And combines a combination of the 2. In this one, you have 2 things on top, so this is joint. And my constant variation is the 3. And look at this one. Notice how they're both on top, but it's only one thing, so this is direct. And my constant variation is the 11. And that's it.